Peterson solution. The software-based solution for the critical section problem is known as Peterson solution. We use Peterson solution when there are only two processes which are involved in the critical section. That is, when two processes shares the common code, then we use the Peterson solution. If the system contain more than two processes, at that time Peterson solution is not possible. If we use the Peterson solution for solving critical section problem only when two processes are present. Suppose we have two processes P0 and P1, and Peterson solution requires two data items or data structures. Those are int turn and boolean flag. Here int turn, turn is an integer variable, is nothing but it stores the integer value, and the turn indicates whose turn is to enter its critical section. Here the value of the turn may be either 0 or 1 because we taken two processes P0 and P1. Suppose if the turn value is equal to 0, then it says that the process P0 is allowed to execute or enter into its critical section. Suppose if the turn value is 1, that is turn equal to 1, then the process P1 is allowed to execute its critical section. And the next data structure is boolean flag of 2. Here the boolean, it holds either true or false, and the flag is an array. The size of the array is 2. It holds either 0 value or 1 value. Why? Because we taken the processes P0 and P1. The flag array is used to indicate if a process is ready to enter its critical section. For example, flag of 0 equal to true. That means, or the value indicates the process P0 is ready to enter its critical section. If suppose flag of 0 is equal to false, that means flag 0 is false, it means the process P0 is not interested to enter into the critical section. The initial values of flag are always false, that means flag of 0 and flag of 1 are false. If flag of 1 equal to true, it means the process Pi is interested or ready to enter its critical section. And the next one, this is the structure of process Pi. Starting, do flag of I equal to true, turn equal to j, and the while statement. This is all the entry section. After the entry section, critical section, and then exit section, remainder section. First, here while of true, in the sense it's always true. Next, here flag of I is set to true. It says that the process Pi is interested to execute or enter into the critical section. Next, turn equal to j, that means Pi is giving a chance to Pj to enter into the critical section. Turn indicates whose turn it is to enter the critical section or execute the critical section code. And the next one is while statement. While of flag of j and turn equal to j. Flag of j. Here the logical and means when the logical and is true, it true when both are true. If flag of j is true and turn equal to j, then only the while condition is true. Otherwise any one condition is false, the total loop is false. Suppose if one of these conditions is false, then while condition is false. If both conditions are true, that means PJ is interested to enter into the critical section, or PJ is already present in a critical section. So PI process has to wait up to completion of PJ process. After completion of critical section, the flag of I equal to is set to false and PJ will execute the critical section. Okay, we will discuss through two processes here. Here the process 0 and process 1, that means P0 and P1. Here initially flag of 0 equal to true and turn equal to 1, that means the process 0 is given a chance to process 1 to execute the critical section. And then while of flag 1 equal to true and turn equal to 1, here flag of 1 is already set to true and turn equal to 1. Here the turn value is 1. At a time turn value is set to either 0 or 1. The flag value is set to either true or false. But turn value is set to either 0 or 1 at a time. Only one value, that means here while of flag 1 equal to true and turn equal to 1, flag of 1 is set to true and turn value equal to 1, so both the conditions are true, that means the while statement is true. That means the process 0 is wait until the completion of process 1, then the execution move to the critical section of process 1. Process 1 will execute the critical section code. After completion of critical section, flag 1 is set to false. And then we again move to the process 0. And then again execute the while statement. While of flag 1 equal to true. We already set flag 1 value to the false. So the condition is fail. In logical and any one condition is false, then total while statement is false. So then now process 0 enter into the critical section, and then end of the critical section, again the flag value is set to false and then exit from the process. Here again we have, finally we know that any solution to the critical section must require the three requirements. Those are mutual exclusion, progress, bounded waiting. Now we have to check whether the Peterson solution is satisfying these requirements or not. Now first requirement is mutual exclusion. What is mutual exclusion? The critical section should contain only one process at a time. The other process should enter into the critical section when the critical section is free. Let's check whether it satisfies or not. At a time either P0 or P1 can enter into the critical section. Only one process can enter into the critical section and other process will wait up to critical section is free. So Peterson solution satisfies the critical section problem, mutual exclusion. Next one is second requirement is progress. Let us assume critical section is free and processes P0 and P1 are interested to enter into the critical section. Then the decision about which process should enter into the critical section with finite amount of time. Progress means out of all the processes we have to consider interested processes which should enter into the critical section, and the corresponding decision should be taken in a finite amount of time. So here again the second property progress is also satisfied. Why? Because process 0 and process 1 both are willing to enter into the critical section, but at a time we will given a chance to one process. Next one, third requirement, that is bounding wait. Let us assume P0 in a critical section and P1 is sent a request to the enter into critical section. Let us assume that P0 completed all its operations. So P0 comes out from the critical section. And again assume that if P naught also put a request to again enter into the critical section, so there is a competition between P naught and P1, which process need to enter into the critical section. Let us assume that O is given a chance to P naught to enter into the critical section one more time. Here there is a problem. Why? Because P1 is waiting from starting onwards. So the busy waiting is occur. Here the bounded waiting means there is a limit how many times may enter into the critical section. Here after completion of critical section, it executes flag of value is set to false. That means it will give a chance to other process to execute the critical section. It is also, that means the third property is also satisfied. So finally Peterson solution is the best solution in order to solve critical section problem.